think you're in charge? Well, think again.
There is nothing wrong with your television set. Do not attempt to adjust the picture. We are controlling transmission. We will control the horizontal. We will control the vertical. For the next hour, sit quietly and we will control all that you see and hear. We repeat, there is nothing wrong with your television set.
Yes, The Outer Limits from 1963. Despite what that big TV voice told you at the start of every show, they weren't in control of your television set. Nope, they just didn't want you to turn your TV off. And The Outer Limits was such good science fiction, you were bound to stay put. But that iconic opening presented a chilling premise. Someone had the power to invade your living room and fiddle with your TV.
Now, fast forward a half century. You still control your television, but maybe not for long. Thanks to digital technology, they are now digital hackers. They may have access to what you're watching and complete viewing habits. But then maybe you don't care whether anyone knows that you're slumped on the couch all weekend.
We can change the focus to a...
Okay, I got a bucket of maple bacon popcorn, room temperature beer, 8 seasons of The Outer Limits, plus the entire Blu-ray collection of My Little Pony. The wife is out of town, so this binge weekend is just between you and me, Mr. Bubbles.
And that guy in the Ukraine who hacked into your television set. He got access via the digital thermostat, with the Internet of Things promising to hook 50 billion devices to the web. Jumping from device to device in your home will be easier than navigating to grandma's. And once he's in, it's a short hop to your Social Security number and login passwords. But losing your anonymity in the digital realm may be the least of it, because your entire biology is packed into your DNA, and you shed DNA everywhere you go. I'm Molly Bentley.
I'm Seth Shostak, and welcome to Big Picture Science, produced at the SETI Institute, where researchers investigate the nature and origin of life. On Big Picture Science, we step back to get the wide-angle view on science and technology. And sure, everyone agrees that modern technology allowing us access to information and to one another has enormous benefit. But how much of our anonymity are we willing to trade for that?
Do you value your privacy? Are you also online? Well, then your private world is more public than you think. The expensive ski boots that you bought off Amazon, your Google search asking, why are manhole covers round, which is a common search question, by the way, and the vacation photos that you tagged on Facebook, all that information is a commodity being traded in the digital market.
Most people think that they are Facebook customers, but in fact, they're Facebook's product. You are the thing that Facebook sells to their real customers, which is advertisers.
And those data are used against you in a multi-billion-dollar industry in ways you don't realize. Now, the guy you just heard, he's had a long career in law enforcement as a counterterrorism agent and an undercover officer. He's worked with the Los Angeles Police Department, Interpol, the United Nations, and NATO. He's tangled with bad guys face to face. But even he is nervous about how effective criminals can be in the new, wild Wi-Fi West.
My name is Marc Goodman, and I study the future of crime and terrorism. And frankly, I'm afraid by what I see.
Marc Goodman is now a global security advisor and founder of the Future Crimes Institute. His book is Future Crimes. Everything is connected, everyone is vulnerable, and what we can do about it. And we'll talk about that. But first, his story of Matt Honan. You may already know it. Matt was no technology hack when he got hacked.
Matt Honan was a reporter at Wired magazine, deeply technically proficient, and he was sitting at home one day playing with his 2-year-old daughter on his knee, and he looked up on the desk and he saw his iPhone powered down and rebooted. And when he looked at it turned back on, it wasn't his standard iPhone. In fact, it said, please register your iPhone, which he thought was odd because his iPhone was registered. So he walked over to his iPad and he saw the same thing was happening. And then he went to his laptop and he saw it too had been erased. And it turns out a hacker had gotten into his world and erased his laptop, his iPad, his iPhone. And in that hack, he lost 8 years of Gmail. He lost all of his work documents. He lost photographs of his 2-year-old daughter, every photograph from the time she was born until the age of 2. And even he lost photographs of long departed relatives who had died. So his whole digital life was taken over and erased.
What was the hacker's motivation in the first place? To empty out Matt's bank account as retribution for an article that he wrote for Wired? Nope. Marc Goodman says that the hacker's motivation was frivolous, and that underscores how serious the threat could be when a thief's goal is truly sinister.
Well, it's really interesting. It was done by a young hacker from Eastern Europe, and the reason why he went after him, the hacker eventually admitted, is because he wanted Matt Honen's Twitter handle. His Twitter handle was @Matt, M-A-T, only 3 letters, and the hacker said, wow, I would like that. So just in an effort to get his Twitter handle, he took over his whole digital life and just said, I'm going to do this.
He incinerated his personal effects, as it were.
Absolutely.
And was Matt particularly vulnerable? Was he more vulnerable than I am or you are?
He was more high profile because of his position in Wired magazine, but he was just as vulnerable as all of us. In fact, all of us have more in common with Matt Honen than we realize because we're storing more of our digital lives in the cloud, whether it be our photographs, our videos, our appointments. All of that data is online and can be taken out.
But I have a gazillion passwords. Doesn't that protect me?
No, a gazillion. As Matt Honen said after he was hacked, he wrote a cover story in Wired magazine which basically said it's time to kill the password because the password didn't protect him. The bad guys were able to socially engineer his password, figure out what it was, deal with third-party vendors, and trick him to get it.
But that sounds like a bad password.
No, it wasn't actually the length of his password is that they presumed it's kind of complex, but the hackers presumed Matt Honen, like most Americans, would have an account on Amazon.com. So they guessed at what his Amazon.com email was. They contacted Amazon. They asked him to reset his password. They sent that to a dummy account, and through that were able to get in. So it was social engineering.
My goodness. So it didn't matter what his password was. Technology's great. I mean, let's face it, it makes our lives easier. Somebody asks me, okay, who voiced that weird robot in the movie Interstellar? I mean, just get the answer straight away on my cell phone, whatever. Google, it sounds free to most people. Maybe we have to look at a few banner ads, but this isn't really how we're paying for that service, is it?
No, in fact, the most expensive things in life are free. We think the internet is free. We think Facebook is free. We think Google's free. We think that flashlight app that we just downloaded were free. But as most people will find out, they're paying, and they're paying with their privacy. All that data that you give up, your social network, your graph, your friends, what high school you went to, your parents' name, what you like and don't like, all of that is monetized by companies like Facebook. Most people think that they are Facebook customers, but in fact, they're Facebook's product. You are the thing that Facebook sells to their real customers, which is advertisers.
So, in other words, they're just tricking me with this free service. I mean, maybe tricking isn't the right verb.
No, they explained it to you perfectly after you read the 9,000-word terms of service. Every little bit of it was in there.
I think I found some guy in, half a hemisphere away who has read one of those terms of service texts.
I have read and agreed to the terms of service is the biggest lie on the internet. Nobody has ever read those. And in fact, a study was done. They said if you read all the terms and services that an average American was presented on an annual basis, it would take 78 days of your life every year to read them, to keep up. So companies are counting on that. They're putting these really oppressive terms of service, and they're more like terms of abuse, and we click on it.
Yep. Well, at least I'd be literate after those 78 days. Just think of how interesting I'd be at parties. How does this set us up for risk? You say we are the product of social networks, search engines, and so forth. How does that set us up for risk? I mean, it just sounds like, well, I'm telling everybody the nooks and crannies of my life, but how does that make me vulnerable?
Well, there's 2 ways. One is the standard business model. So if you value your privacy, then the fact that you like X or Y or maybe investigating a particular disease online, that gets sold to these companies as well, to these massive third-party data brokers in a multi-billion-dollar unregulated big data industry. So what you like, what you don't like, what your religion is, your sexual orientation, your particular proclivities, that all gets sold. And that data is used against you in ways that people don't realize. In Future Crimes, the book, I tell a story of a dating site called OkCupid. And it's a free dating site. And when you fill out your profile, they ask you, are you looking for men or women? How many people do you date? What's your sexual history? And one of the questions they ask you is about your drug use. Do you use marijuana? Do you use cocaine? How often, etc.? And I guess if you like using cocaine and want to date somebody else who uses cocaine, you put that in your profile. But what people didn't realize is OkCupid, the free dating site, the minute you said, yes, I use cocaine, they were dropping a cookie on your hard drive and then selling that data onto third-party brokers who were then selling it to employers. So the next time you apply for a job at a company and you're turned down, you'll never know that the reason you were turned down for the job is because they know that you're using cocaine. So data that we freely provide in one venue can be used and repurposed elsewhere without our permission because it's agreed to in the terms of service.
Do I have a lot of cookies on my computer? I mean, I never look.
Yeah, you have probably tens of thousands of them. And there are third-party tools that you can use to help erase them and get rid of them. But now there are even more persisting cookies that even if you erase them, they stay around.
You've had a long career in law enforcement, Marc, as a counterterrorism agent and undercover officer. You say you've seen a lot and that the criminals have taught you a lot, and in particular how they use technology. What have you learned from the criminals in this regard?
Well, they don't have to ask permission. They don't pay taxes. They don't fill out forms. They're unencumbered by bureaucracy. There's lots of quotes in the book Future Crimes, and one of them is from Woody Allen. And one of his quotes is, organized crime brings in $40 billion a year in America and spends very little on office supplies. So it brings you into that mindset, which is that they're completely free to do as they will to transcend international borders. They don't have to put in acquisition requests for their technology. They just get what they need. And so what we're seeing is that in effect, they are early adopters of technology. In the 1930s, they had getaway cars when the cops were still on horses and on foot. And today, when I was a young patrol officer, we saw criminals, drug dealers had pagers and 5-pound cell phones long before any cop I knew ever had one. So that's continuing those trends today. We're seeing criminals use artificial intelligence, synthetic biology, robotics, machine learning. All of these latest tools are in their arsenals.
So they're actually very sophisticated. I mean, they're very technically adept. I think you wrote that no computer has been built that can't be hacked into by these guys.
That's exactly correct. And that's one of the biggest challenges that we face is that every computer is hackable. It's just a matter of the amount of time and intention that people put into it. Former FBI Director Bob Mueller famously said there's only two types of computers, those that have been hacked and those that will be. And the challenge for us is that computers are running much more of the world than people realize. So people think, oh, I have a laptop, that's a computer, and they may realize that their cell phone's a computer, but they might not think that their Xbox 360 is a computer, or in fact their automobile is a computer. Every modern car has over 200 computer chips in it that control everything from the cruise control to the windshield wipers to the ABS brakes and even the airbag. And that's all hackable. Somebody halfway around the world can dial into your car as it's cruising down the street and turn off the brakes. So the bigger challenge for society, and one of the reasons why I wrote this book, is it's not just the computers of today that are hackable, but the ones of tomorrow, particularly as we drive towards the Internet of Things.
Well, let me get back to that. The Internet of Things. Everything's going to be connected to everything. So I don't understand how this makes me vulnerable, though. I mean, are they going to hack into my, my heating system or at home or something like that? And if so, why? It's
funny you say that. So as it turns out, you're probably familiar with the Target hack that occurred last Christmas or 2 Christmases ago. In that case, everybody heard that the Target point-of-sale terminals were hacked, but most people don't know how they got in. And they got in through the air conditioning. Target had used a third-party HVAC company to manage their network. One of the employees there got hacked through a phishing email. His computer got taken over, which allowed the hackers to get into the Target contractor system, into their main system, into their financial management system, into the cash registers, into the point-of-sale terminals. So the subtitle of Future Crimes is Everything is Connected, Everyone is Vulnerable, and What We Can Do About It. And the trick is that because the system complexities are so great, you don't know that your thermostat is connected to your cash register. And those are the challenges.
Well, then finally, because everybody who is listening to this, Marc, is probably asking themselves, well, what am I going to do? I mean, if Target and these big companies, they can't protect themselves, what can I do? I could throw away all my devices. I'm not about to do that. Is there anything you recommend?
Yes, in fact. So in the book, there's things that I recommend of what we can do as a nation and as a society to protect ourselves. The last few chapters of the book are filled with solutions. But practically for the individual, small business, family, etc., there is an appendix which lays out a whole bunch of steps that folks can take. And I've narrowed them down to 6. I did some research, and it turns out the Australian Ministry of Defense studied tens of thousands of cyber attacks, and they identified 6 steps that people can take with regards to their passwords, encryption, how they administer their computers, etc. And if you take those 6 steps, you can reduce your cyber threats by 85%.
Can you give me one?
Yeah, so I created something called the Update Protocol, UPDATE, and each letter stands for something you should do. Update is keeping your software up to date. There are constantly new attacks that are detected, and if you're running old software, that's how criminals get into your computer. So set your software to automatically update. D, download. Watch what you download. Most people that get infected are downloading things from bad places, the torrents, the nets, stealing movies and videos, pornography, whatever it be. All of that is riddled with viruses. A, this is a big thing that people wouldn't know. Most of us, when we get a computer, we have to create an account when we get the machine at home. That account by default is what is called an administrator account. That means it's got maximum privileges to do anything on your machine. When you go ahead and download a bad attachment or click on a bad link, if you are logged in as administrator, then that malware, those viruses can run automatically. Instead, what you should do is create a user account that you use for all your daily activities, surfing, writing, etc., and only use the administrator account when you need it. So if you open a PDF and it says, please enter your administrative password, it's obvious it's trying to do something it's not supposed to. And there are several more tips in the book along those lines that will cut people's cyber threat by 85%.
Marc Goodman, thanks so very much for being with us today.
Thank you. The pleasure was mine.
Marc Goodman is a global security advisor and founder of the Future Crimes Institute, and he is the author of Future Crimes: Everything is Connected, Everyone is Vulnerable, and What We Can Do About It. I still can't help but think if I have just a really clever password, no one can break into my private files.
It's somewhat discouraging that he maintains that none of those passwords is going to protect you. Only 2 kinds of computers. It's going to be hacked or it has been hacked, and the passwords don't help. And I think of all the pain involved in trying to keep track of all my passwords. But, the Internet of Things argument that he makes is particularly chilling because, of course, that's what you want. You want to connect those devices in your home so that the coffee is made in the morning, or it monitors when you're running out of milk, or that kind of thing. And that opens up a whole bunch of windows in your house without locks. It's scary.
I don't want to connect everything in my house.
Well, don't be a Luddite, Molly. Don't you want your fridge to let you know when you're running low on yogurt?
My eyes can tell me when I'm running low on yogurt. And as for coffee, don't you enjoy getting up in the morning and just making a cup of coffee?
Yeah, well, actually, I don't. But I'm not sure that this would help. Yeah.
Coming back to the Internet of Things and that idea of the thief coming through your heating system, that's not an entirely new idea.
Okay, Jimmy, it's up here. Keep crawling. There's the safe room up there. That's where they keep their safe and their cash.
My knees haven't hurt like this since I took communion on that bed of hot coals. Why can't we just break a window like normal thieves?
Because there's an alarm. No one suspects we'd come through the heating system, and it gives us access to the whole house. Look, through that register. That's the kitchen, see?
Wow. Hey, can you really live off Twizzlers and vodka?
And there's the laundry room.
Looks like someone enjoys the Renaissance fair. You sure learn a lot about people this way.
Yeah, nothing's private anymore. Oh, okay. There's the safe. Let's get in there.
Okay, so you're now going to change your passwords, delete your Facebook account, and pay only with cash? Think that'll make you anonymous? Well, you may have taken care of your digital fingerprint, but what about your dandruff? You might give yourself away when you flake out.
It's They Know Who You Are from Big Picture Science.
Support for Big Picture Science comes from Google. The Making and Science team at Google aims to inspire the next generation of scientists and makers by helping them develop a deeper understanding of the world around them. Learn more at makingscience.withgoogle.com.
Well, after listening to Marc Goodman, you might be hatching a plan to swap your computer for pen and paper, your digital thermostat for a fireplace, and all your credit cards for a stack of Ben Franklins. Yes, sir, you're going off the grid. But you are planning to keep your epidermis, right?
Packed into every one of your skin cells, well, into all of your cells, is a helix of chemical instructions that code for your physical being. Now, your DNA doesn't know that you're sporting a goatee or a chest tattoo, but it might reveal that you need to wear glasses or have a talent for the oboe. And as long as you have skin, a few strands of hair, and sweat glands for that matter, whenever you leave a room, you have the potential to leave some of yourself behind.
DNA is the stuff of crime investigation. It's usually taken from a crime scene to compare with DNA already on record. But now there's another way to find a perp. New technology will allow law enforcement to create a visual portrait of a suspect right down to the eye color from the DNA sample alone. That's a big change from the situation today when a police sketch is only as good as the witness.
Okay, how old?
Early 50s.
And a long face, you say?
No, longer. Ears that kind of stick out. And then high cheekbones.
Okay.
Receding hair. And what's left of it, it's dark and it's parted on the side in kind of a big wave.
Mm-hmm. Like this?
Yeah.
And his chin?
No, he had one of those hipster beards along his face.
Uh-huh.
No, make it more scraggly. Yeah, that's him.
This is your guy?
Yeah, that's the guy I saw.
This guy?
Yep, I'm positive.
So you saw Abraham Lincoln robbing a convenience store.
The sketch artist's charcoal may yield to computer software that digitally creates a physical likeness based on a snippet of DNA. That computer portrait could be matched with a mugshot in a database or simply passed around a neighborhood where the crime occurred.
Forensic scientist Susan Walsh says she's helping develop DNA phenotyping, as it's called, for crimes where there are no witnesses, and investigators want an idea of what the criminal looked like. And to develop such tools, the Department of Justice has awarded her a $1 million grant.
But the phenotyping tools could also be used to provide portraits of not just criminals, but also important historical figures who lived before the era of photography or even portrait painting, as long as we can get a smidgen of their DNA. Dr. Walsh says that technology is still being developed. Hair and eye color can be determined now, and facial shape is next. But as long as any of us shed DNA, it may be harder to walk in and out of a room without leaving a trace.
And we've developed already an eye color prediction tool and a hair color prediction tool. And in the process right now, a skin color prediction tool. We do envision adding a trait each additional step. So right now we have eye, hair and skin color. Next, and currently there is research ongoing to get facial parameters. So we hope one day in the very near future, I believe at least in the next 5 to 10 years time, that we will be able to produce this computerized printout that will include all your pigmentation, so your eye color, hair color, skin color, and your facial parameters, so exactly how you look looking in the mirror.
How hard is that? Because eye color is determined only by a few parts of the genome, right? Just the few places in the DNA where you can point to it and say, that's what determines whether your eyes are brown or blue. But if you're talking about what somebody's face looked like, there are so many different characteristics. How wide it is, and is the nose sharp or broad? Those sorts of things. That sounds like a much harder problem.
It definitely is. But we know from just eye color, as you say, as an example, we know that the genetics is there. And you have to think of a face as a structure, and you can break down several aspects or landmarks within the face, just as you described, distances between the eyes, distance between the nose, nostrils. All these aspects can be measured, and basically you search through the genome looking for specific measures.
How do you determine which parts of the genome would affect the appearance of a face? Do you do that by just comparing a whole lot of DNA with a whole lot of faces, or do you have some sort of mechanistic approach to this where you say, I know that part of the DNA folds these proteins over here and they have something to do with the face? Do you understand it, or you just sort of match faces and DNA?
Well, there are several steps, but you have it pretty close with your first example. We do find that using several thousands of individuals, having their genetic code and having imagery that's associated with that person, and having both characteristics, the genotype and the phenotype, and then searching through the genome for matches or for correlations, we do have an indication then of the possible hits that could be associated or related with your genes and your face.
Just so I have some idea of the challenge here, Susan, we discussed the fact that eye color, hair color, that might be determined by a very small part of your DNA, a little bit of the genome there. But how much is involved in something like, the shape of your nose? Is that far more complex, or is that still just a couple of genes that we need to identify?
This is extremely complex. This is a polygenic trait, meaning that there's more than one gene that controls the difference in the variation between individuals. And that goes the same for many characteristics. Eye colour, hair colour and skin colour included in those. There are hundreds and hundreds and thousands of SNPs that each give an indication of the direction of a trait, so whether it is a long nose or a short nose, for example. We just try to narrow them down to as minimum set as possible, and that's more for technological reasons in genotyping.
What about age? Can you tell that from the DNA? Because after all, anybody who's over 40 knows that they don't look the same as they did when they were 20, okay? And so if maybe the DNA tells you how old the individual is, and I don't know that it does, but if it did, then maybe you could somehow correct for that?
Absolutely. As I said, all parameters come down to genetics, especially with physical appearance, and age is included in this. Right now, there's a lot of fundamental research involved in DNA methylation. So there is an aspect that you can manipulate the DNA code to give us this age-related information, but this is very, very cutting-edge technology and research that's ongoing right now.
Certainly people who follow, if you will, high-profile crimes know that DNA is, the technique du jour to identify criminals. But, of course, in that case, they're just matching DNA found at a crime scene with an established database. But on the other hand, that's very accurate. Maybe the right approach is to, instead of solving this difficult problem, just get everybody's DNA on file. What about that?
Well, my personal view on that is that, yes, I think that if we came to a decision worldwide that every individual born gave a DNA sample and they had a profile, not that the sample was kept, but that a profile was generated for them, just like a social security number, then I do feel that this would help crime immensely. I do not see that day ever coming. So the individual identification of a suspect matching a DNA database profile is how we identify individuals or suspects right now. The area of DNA phenotyping, so we try to get a physical appearance profile, that will only be an intelligence tool. This will never replace the standard short tandem repeat DNA profiling that everyone knows from the CSI shows.
We've been talking about appearance, but of course your DNA controls a lot of other things. Has a strong influence on your IQ, for example, or your musical talent. Heck, my mom was very talented on the piano, and none of her kids seem to have inherited that talent. I don't know whether that'd be useful for criminal investigation, but it might be. Well, it might be. I mean, maybe the criminals are playing in a jazz band at night or something. I mean, is there any attempt to find out anything else other than what they look like?
Absolutely. Even if you think about it on a pure investigative tool level, what if we could tell what hand the person preferred? Were they right-handed or left-handed? And this is certainly an addition that could really help an investigation. That is taking into other factors into account, such as psychological profiling. Maybe that is down the line. I'm not too sure, because that's a huge environmental factor to add into that. But for definite, our genes tell our phenotype, so let's focus on that right now.
Well, at this stage, can anybody be convicted on the basis of this kind of phenotyping, this identification based on DNA fragments found at the crime scene? Are we that far?
No. I'm not too sure that we will ever get that far. It would really have to be a very, very individualized prediction. And right now, as I said, we're at the broad category levels, and there are too many individuals that would overlap on many colour or facial appearance predictions. So unless we can get a very, very individualized printout, which is the research area I'm trying to work in right now, we're not at that level right now. This area, as I said, is a pure intelligence tool. It basically gives the investigators a lead, a direction, for them then to go to the suspect in question that we matched with our physical appearance, and then obtain an STR, or short tandem repeat DNA profile from them. It is then that profile will take them to court.
Well, going beyond crime fighting, could we do other things with this technique? I mean, could we take some DNA from King Richard, which the English just dug up and reburied, and, accurately reconstruct his face at some point? Maybe, determine what some of his talents were.
I actually did work on the King Richard III case. We worked with Turi King, who was the author of the paper. She did all the hard work, basically, and managed to get a full genomic profile of ancient DNA, which was extremely difficult. And we did predict his eye and hair colour.
Tell us what they were.
Basically, it came down to that we were 99% sure that he had blue eye colour, and that we had a high probability that he had a lighter brown to blonde hair colour. And that indication shows us that possibly he was blonde as a child and darkened with age. And from that, and the reason why she worked with us on this paper, was that she could associate the nearest portrait painting with our prediction, because it was all posthumous paintings that were done. So nothing was painted in his lifetime, it was only after he died. And there were several portraits out there that were differing in the colour of his eye and hair, and we were finally able to prove that more than likely it was blue and brown to light blonde hair colour that he had.
This is going to be bad news for brown-eyed actors who want to portray King Richard, I would say.
Absolutely, and the whole writings behind William Shakespeare, who insisted that that's what he looked like.
This may put the people who take skulls of some of our, pre-hominid ancestors or hominid ancestors anyhow, and then they use clay or whatever, and they make their faces, and you see them in the museums, but we could do a lot better, couldn't we?
Absolutely. And right now you can do a facial construction if you have bones, as you say, and you can use my tools right now to give the eye colour, hair colour and skin colour aspect of that. And that's just going to get better with more research and more time put into it. And that's exactly what I hope to do with the grant that I received, and what several groups hope to do when they receive funding.
Could the public eventually do what you're trying to do, Susan? Could they get the tools? Sequencing DNA is going to get cheaper all the time. Maybe they can get some software and then, pick up a speck of skin on their spouse's clothing and track down who it is that person may be seeing. I mean, I can see a lot of maybe problems here.
I can see where some individuals may think that there may be issues, and there have been a lot of papers and law studies into the ethics behind such a technology. Where I come from with that is, yes, you can do sequencing. Anybody can send a sample to a facility to get it done. Yes, you can look at our papers. We publish all of our information. We like our scientists to be able to use the data that we find out. But what really is it going to tell you? It will tell you the picture of an individual, which any CCTV camera can do the same thing. So I don't feel that there's a breach in ethics. When you walk down the street, you're on 20 to 50 cameras anyway. When it comes to crime scene sampling, if a sample is left at a crime scene, we as investigators and scientists are allowed to do any type of test on that sample because it was left at a crime scene. That's in the United States. So I don't feel there's any breach in ethics. As I say, you're on CCTV every day.
Susan Walsh, thank you so very much for speaking with us.
Thanks very much for having me.
Susan Walsh is a forensic geneticist at Indiana University, Purdue University in Indianapolis. Well, okay, you might be thinking, that's it. You want your privacy. You're swearing off computers and vigorously loofing your loose skin cells like Vincent does in the movie Gattaca. But thank goodness, at least your thoughts are still your own.
But are they? A neuroscientist on the technology of reading minds. Next on They Know Who You Are. But do you know who we are? Big Picture Science.
Big Picture Science is supported in part by Podiversity. Podiversity offers easy access to ad-free podcasts on Android devices. Your subscription to Podiversity helps support the production of Big Picture Science and your other favorite podcasts. Follow your favorite shows and have new episodes downloaded automatically to your Android device. You can download Podiversity from the link at bigpicturescience.org or at podiversity.com.
So they know your name, your social security number, that your eyes are brown, you're left-handed, and you have a cleft chin. Your identity is totally exposed. But at least they can't read your mind.
we are developing technology to read minds, and my name is Marvin Chun, a cognitive neuroscientist at Yale University.
They say the eyes are the windows to the soul, but in Dr. Chun's lab, you might say the eyes are the windows to your thoughts. His team is using sophisticated neuroimaging equipment, such as an fMRI machine, to decode brain activity associated with your looking at specific images.
Now, it's not the kind of mind reading you might see in a movie. That's usually a guy sitting there with a bunch of wires sticking out of his head while a scientist listens in on his internal dialogue. But Dr. Chun's lab is taking a tiny step in that direction. By recording and analyzing neuronal patterns produced when the subject is looking at a test object, he and his researchers can recognize when they're thinking about that same sort of object later. Their brain activity gives them away. With this method, Dr. Chun's team was able to reconstruct images of faces simply by having volunteers think about them.
As a first step, we are asking people to look at images because perception generates strong signals and clear signals in the brain. And then we are using functional magnetic resonance imaging scanners to read out those signals. And we have computational tools that allow us to try to decode what those signals are indicating.
Is the brain activity when we look at an image, is it localized? Is it scattered throughout the brain? Does it matter?
That's a great question, and it's actually both. The reason why we start decoding with vision first is because the human brain has a very well-developed visual system, and there are areas of the brain that are pretty much devoted to processing visual images, but these areas are distributed throughout many parts of the brain, and we are able to decode signals from many of those regions.
So you would see different brain activity in my brain if I were to look at a cat as opposed to a piece of chocolate cake.
That's correct.
So what you're doing is translation, really. The brain puts out all these signals, and you're translating it back into an image?
That is correct, yes. I think translation is a really nice metaphor because that is essentially what we're doing. Images come through the eyes. They get processed by your brain in ways that allow you to distinguish something like a chair versus a car. And what we're able to do is, by learning how those images relate to the signals in your brain, we can make guesses as to what image you are looking at.
And you use a machine, an fMRI machine. The F is the functional magnetic resonance imaging machine, and that means you're looking at the brain while blood is flowing, right? So this is an active portrait of what's happening in the brain.
That's correct, yes. fMRI is building off of the usual MRI technology that doctors use to scan internal structures of the body and look for abnormalities. The functional in that refers to the fact that we are actually reading out the oxygenation level in local brain blood flow. And basically what's happening is that active brain regions consume more oxygen, and so there is a surge of oxygen delivered through hemoglobin to those active brain regions, and that is basically the signal that we are able to read out using fMRI.
We see so many images every day, and are you saying that everything that we look at has a discrete pattern in the brain, and that would be millions and billions? I mean, that would be an infinite number of different signals in the brain, wouldn't it, for cake or a cat or my colleagues or the train or whatever it is?
That's absolutely correct. Your brain is capable of processing an infinite number of objects or thoughts, but what is beautiful about the system that allows us to do this kind of work is that your brain will respond to identical or similar objects in consistent ways. So when you're looking at a cat, yes, there will be a pattern associated with that, which we can decode because that pattern will be similar to the pattern that's elicited by other views of the same cat or even other views of similar cats.
Well, no, it's one thing to look at someone's brain and say, okay, I think she's thinking about a cat. It's another thing to actually reconstruct that cat. Mm-hmm. And you did a study that had some success with that endeavor. I believe your lab did an experiment where you were able to reconstruct faces based on what subjects were seeing. And you started by monitoring the reaction of your volunteers to about 300 faces or so initially. Can you tell me more about that study?
Yes, absolutely. Basically, what we did was exactly what you described. What we're able to do is we are able to literally decode and generate with a computer the faces or a guess of the face that we think or that the computer thinks the person is viewing, and the accuracy of that guess is about somewhere between 60 to 70%, so it's definitely far from perfect, but it's still significantly better than chance. And so as a first demonstration, I think it has generated a lot of excitement. The way it works is that we first present subjects in the scanner with lots of different faces, and we use that to train computer models of the relationship between the image coming through the eyes and the fMRI signals that are generated by that face. And we learn this relationship between the image and between the brain signals as measured with fMRI, and that allows us to build up a computer model. And this computer model now, when presented with a new face, with a new set of brain signals, can mathematically generalize a guess that allows us to decode a novel face that a person is viewing.
It's pretty ambitious to work with faces, isn't it, and code them and then decode them, because the difference between any two faces might be quite subtle, right?
That's actually a fabulous question, because Alan Cohen, who's the lead author on this work, was a sophomore in college. And when he proposed this idea, I thought that it would not work for that exact reason, that faces are too similar to each other. So how in the heck are we going to get a computer to guess what faces people are looking at based on their fMRI signals? I really didn't think the project would work very well. But the disadvantage of using face stimuli also turned out to be a huge advantage in that because faces are similar, there are very nice computer vision models that can describe faces in mathematical terms. And because faces are similar, these tools already existed from computer vision. And the big innovation of our study is use these math models to decode the fMRI signals.
Once you decoded the fMRI signals when your volunteers were looking at faces, you were able to reconstruct the faces based on what the subjects were seeing or based on what they were thinking about. That's really what they're doing.
And more accurately, what they were seeing. We didn't actually do the thinking experiment, although the Bryce Kuhl, one of the authors on the work, has subsequently showed and told me that he's now able to do it based on thought alone.
Okay, that is incredible. Back to the original study, did a computer produce an image of the face? Was it a color portrait?
Yes,
Would I recognize it as a face?
And that's where the math models come in, is that basically what the computer is doing is that it takes a set of fMRI signals and it knows what math parameters come out of that, and it can easily use those math parameters to literally generate an image.
But what does that image look like, Marvin? Is it look like a sketch, a computer drawing, or does it look like
a very blurry computer rendering of a face?
Like a photograph?
It's like a photograph, but it's a very blurry photograph because of the way the faces are generated with these mathematical algorithms.
Does it matter that all brains code a little bit differently? Your brain and my brain will look at the same image, and they might encode those images slightly differently. So how can you generalize and create an algorithm or a program that could read all minds?
So this is where there's the major limitation of mind reading with fMRI comes to play, because this will not work across different people. The models have to be trained within people. It only works for that same person. And so a model for your brain looking at faces will be different from a model of my brain looking at faces. And I don't think it will be soon possible to generalize across people.
Let's get back to that question of what is thought. And I wonder, as a cognitive neuroscientist, how you define thought. Because I may think in images, but I also think in language. So how do you define thought?
I think there are many forms of thought. One can think of things in terms of pictures, in terms of sounds, in terms of like the tune that runs in your head in the morning. And of course, many people are very verbal, and especially when you're thinking about conversations with other people or trying to develop a thesis in one's mind, a lot of that thought will be language-based. So I think the ability to start to decode those other forms of thought will start to emerge, but everyone is starting with vision because it's a relatively well-understood system.
So we could in the future create an algorithm for language and do some of the same experiments that you're doing.
That is correct. Yes, in theory, it should be possible. People are working on such. For example, UC Berkeley has a colleague, Bob Knight, who's working to decode speech.
Now, Marvin, why is it that you're interested in doing this? I don't get the feeling from talking to you that you want to take over the world with your mind-reading machines. You're interested in something more fundamental about how the brain works and decodes images. And what are the larger questions that you're asking?
Yeah, thank you. Yes, I can state for the record that I have no interest in taking over the world, but the reason why I'm interested is because fundamentally as a psychologist and as a neuroscientist, we are interested in understanding how the brain gives rise to all the amazing things that people can do, think, feel, communicate with others. And so fMRI is just turning out to be this incredible tool for answering that question or getting answers to that question. I think fundamentally the applications that I would be interested in as a scientist are, for example, trying to decode the onset of dementia or the onset of mild cognitive impairments. These are the applications in which I'm more specifically interested that I think will also have clinical and practical benefits.
Thinking speculatively for just a moment, with everything that you've described, could you take this technology and one day record a person's dreams? I mean, dreams are filled with images. Could we ever actually play back our dreams or even old memories when the face of our favorite teacher in third grade is beginning to fade, or that funny incident, back when we were 12? Could we play those scenes back?
That would be a pretty exciting, I think, application to be able to provide digital permanence, to these important personal experiences. On the good side, I can say that scientists have already begun to decode dreams. This is a 2013 paper published in Science by a group in Japan, including a researcher named Kamitani. So those capabilities are being developed.
Well, when people raise to you the questions that this work inevitably raises about the ethics of invading mental privacy, how do you respond?
Yeah, absolutely. I think it's of the utmost importance to consider the ethical implications of these new capabilities. At Yale, one of my courses that I teach is actually devoted to discussions of the ethics that are caused by these advances in neuroscience. And my response first is that fortunately, the ability to read out the mind is completely protected by the amendment and the Constitution, because no one's able to read your mind if they don't put you in a scanner. And so I think people should retain the right not to be scanned. They don't want to. And so in that case, no one's pulling out private information without full consent and without full informed consent of a participant. So I think that provides some basic protections. We're not able to just kind of scan people from across the room or anything like that. It does require active participation on the subjects and participants' behalf.
So for now, our thoughts are still private.
For now, our thoughts are still private, and I would hope that continues to always be the case.
Well, Marvin Chun, I can tell you what we're thinking, which was it was a delight to speak with you. Thank you very much.
Oh, no, I appreciate it. Really, really excellent questions. So it was a really stimulating conversation for me. I appreciate it greatly.
Marvin Chun is a cognitive neuroscientist at Yale University. Well, as Marvin Chun said there, at least they're not at the stage where they can read your mind with a scanner like you have in the airports. They can immediately find out what you're thinking. But I have to ask, how can they discriminate between your conscious thoughts and your unconscious thoughts, like, your brain telling your pancreas what to do?
That's not a conscious thought for you?
Well, it hasn't been so far.
That's on my mind all the time. No, you're right. They can't generalize right now. They can't actually mind read in the way that we think of mind reading in science fiction. And it's very specialized. The program has to be tailored to the specific individual, and that individual needs to be actually inside the fMRI machine. And the questions that the scientists are looking at are much broader than that. They're not really wondering what it is that you're secretly thinking about. But this idea of invasion of privacy we looked at throughout the whole show, and we raised the question at the beginning. We have benefits to all these technologies, these important technologies, and then there's the question of how much of your privacy are you willing to let go of to enjoy them?
Well, listen, I'm happy to give up a little bit of privacy for information, right? Search engine kind of privacy. Maybe Facebook, that actually doesn't bother me too much. But where I draw the line is what I see coming down the pike in the next 10 years when it becomes so inexpensive to sequence your genome. Everybody's genome is going to be on file. And that means no matter where you go, you're going to leave traces behind, and they can find that, and they can identify everybody who went to the supermarket by just sweeping the floor. You nor Abe Lincoln will be able to hold up a convenience store anymore unless you wear a hazmat suit into that store.
Thanks to the obvious and identifiable talent that helped produce this show, Gary Niederhoff and Barbara Vance.
Also thanks to financial support from Rena Shulsky-David and Sammy David and the NASA Astrobiology Institute. Big Picture Science is produced at the SETI Institute, where scientists study the origin and nature of life. And a big thanks also to our listeners.
Your ears have been attuned to They Know Who You Are. If you'd like to hear more Big Picture Science, you'll find it on our archive on our website, bigpicturescience.org.
If you're a podcast listener but you prefer listening to over-the-air radio because no one's going to hack radio signals, well, check out the listing on our website of radio stations that carry the program. And if your local station is not on that list, consider letting them know you like this show. Oh, got a comment, a criticism, maybe a suggestion? Throw in some faint praise if you dare, and then email it all to bigpicturescience@seti.org.
Okay, so the guy who did this was old, white hair sticking out in every direction like electricity, a bushy white mustache, and a German accent. Hey, why aren't you sketching any of this?
Right.